get on started. Here we go.
Welcome, everybody. We'll give a minute or so for everyone to join. All right, as everybody's joining, I think we'll go ahead and get started. So, hello and thank you for joining Module 3 of our Electric School Bus Familiarization webinar series. This is High Voltage Safety Considerations. We can go to the next slide. So just a couple housekeeping notes up front. Controls are located at the bottom of your screen, and we will be taking questions after each presentation, so please submit them via the Q&A button down there. Next slide. We are recording this webinar and it will be posted, so if you speak or use video, you are presumed to consent to recording and use of your voice or image. Next slide. And the Joint Office, our mission is to accelerate an electrified transportation system that is affordable, convenient, equitable, reliable, and safe. And our vision is a future where everyone can ride and drive electric. Next slide. The Joint Office does support several programs that were established in the Bipartisan Infrastructure Law, which you can see here. And that does include the Clean School Bus Program, which distributes $5 billion in support of electric school bus deployments. Next slide. To support EPA's Clean School Bus Program, the Joint Office has partnered with EPA and the Department of Energy to provide free technical assistance to school districts that are currently receiving EPA funds or are planning to apply for future rounds of funding. So the goal here is to provide school districts with the knowledge, tools, and information needed to successfully plan for and deploy clean school buses. These eligible entities, they can request assistance by filling out the online contact form at driveelectric.gov, or you can get there via this QR code. And then you're also welcome to email us at cleanschoolbusta@nrel.gov. Next slide. Here's some examples of how we can help, but inquiries are not limited to these topics. Please contact us on anything from simple questions to complex, in-depth assistance. We are also available to discuss or review your ideas or plans, or just be a sounding board along the electrification process. Again, this service is provided free of charge with no strings attached. Next slide. So if you're here, you know this is our electric school bus familiarization webinar series where we are presenting 4 modules on the fundamentals of ESP technology. The recordings for modules 1 and 2, they are up on driveelectric.gov, and we will be producing testing materials for all modules once the series is complete. Next slide. So today we do have 3 great presentations for you, and we will have Q&A after each of them. First up, we will be Brad Beauchamp from Bluebird Corporation with an overview of ESP high voltage and high voltage risk and safety. Then we will have Brandon Reed from Lion Electric with worker protection. And third, we'll have Angel Yin from BYD Ride covering the required skills and knowledge for ESP technicians. Next slide. So today's moderator will be John Chavone. John has been involved with transit bus maintenance and technology for nearly 40 years. He served on the APTA staff, authored several transportation research board studies, and is now working with the center to advance frontline worker training and apprenticeships. So over to you, John.
Okay, thanks, Ryan. Thanks all for attending. Next slide. So as Ryan said, this is the third of our presentations on high voltage safety considerations. Next slide. And the mission of the International Transportation Learning Center is the advanced training on a joint labor management basis. We feel that training is much more effective when both sides participate. We organized a similar webinar series for transit buses a few years ago during the pandemic. It went over well, and NREL asked us to do the same for the school bus side. And the purpose here is to provide introductory information. We're not expecting anyone to be able to work on an electric school bus after this presentation, but it's meant just to give you the foundational information that you'll need to get obtain further training. Next slide. So we have the three presenters as Ryan described, and they'll all take place just momentarily. Next slide. Here's key terms that will be used throughout the webinar series. We thought we'd use it here. I don't mean to go through each one of them, but as you download these webinars, you'll have the key terms and what they mean. Next slide. I thought I'd just take a minute to bring everyone up to speed on the major components and power flow of an electric school bus. You know, it is a battery electric vehicle, and as such, it needs to be charged from an external source. If you look at number 1 on this diagram, that's a charge port where the charge cable and it gets plugged into. Number 2, the green, is the energy storage system. It contains the various battery cells. The batteries, is important to note, are direct current or DC, like traditional vehicle batteries, but at 300 to 900 volts, not 12 to 24 volts that you're typically familiar with. And that energy storage system is located between the frame rails below the floor. And because the drive motor is alternating current or AC, like your household current, number 3 in this diagram is an inverter, and that essentially converts the battery DC to AC. Number 4 are the high voltage cables that carry the high voltage throughout the bus. Number 5 is the AC traction motor. Again, it's AC, and it drives the bus wheels. And because there's no internal combustion engine, no way to really drive the belts, either directly or drive the various accessories via belts or direct drive. Equipment like the air conditioner, compressor, air compressor, and power steering pump are done electrically. Just a few words on the safety. You know, buses are now under warranty, and you're having that work done by your dealer. But at some point, that warranty will end, and you will be responsible for your own repairs. To be safe, you'll need to upgrade your basic electrical skills. You'll need to become familiar with AC and high voltage, and it's the only way to remain safe. You know, there's no experimenting here. You really need to know what you're doing. So that's training is very important. And this essentially will be the first step in your training. Next slide. And with that, I'll introduce Brad Beauchamp from Bluebird to talk about, just give you an overview of ESB, high voltage safety, and the risks involved. Brad?
Hello, and thank you, John. As John had mentioned, we've kind of gone through the first phase, which is getting maintenance staff and technicians familiar with the electric school bus. And as these vehicles start to accumulate and get age and mileage behind them, they'll eventually, as John mentioned, be out of warranty. So starting to move into that second phase, which is technician familiarization of and the overview of the high voltage and high voltage risk as well as safety here. So I'm Brad Beauchamp, EV product segment leader at Bluebird. Roll me forward. So when we're looking at the electric school bus and risk, we need to identify how we can stay safe and who needs to stay safe. We also need kind of a guideline to follow. And OSHA has prescribed NFPA 70E as kind of the text and language and guidelines to follow as it relates to safety. So we're going to talk a little bit about high voltage safety itself, because there are some basics just that relate to high voltage that are good not only for electric school buses, but every electrical application. Examine the electric school bus and what's needed for personal protection equipment. Touch on, which will be touched on later, lockout, tagout, and then kind of compare where we're at in the three modules or three levels of training that are out there in electric school bus. All right. So when it comes to electric school bus, again, technicians and maintenance staff need to be familiar as well as drivers, but it goes beyond that. You know, those that are even just bus aides on the bus need to understand the electric school bus, the supervisors and shop foremen, all the way through, transportation directors, those that are routing these buses, the trainers, the yard assistants, and those that are charging or fueling staff, right? Those that might fuel diesel may also be responsible for charging. So it's important that every one of those in the electric school bus arena has a good working knowledge of electrical safety and where that partition is on things that they can manage on the bus and things that they might need additional technical support on. Roll me forward. So I mentioned the National Fire Protection Agency, and obviously NFPA has a number of NFPA 52 is around natural gas and natural gas power vehicles and shop practices. NFPA 58 is propane. NFPA 70E covers a lot about the protection needed for electric vehicles. And can I be cited for not complying if I'm working on an electric school bus per se? Yeah, you actually can under the Code of Federal Regulations. So CFR 29 actually has through OSHA a prescription. So you really need to understand NFPA 70E so you can prevent potential injury or death, not only to you, but to those that are surrounding you as you're interfacing with the electric school bus. Roll me forward. So basically, this is part of the National Electric Code. So it's done in conjunction with NFPA. It's distributed to help people understand standards and practices and staying safe for electrical safety in the workplace. And because electric school buses are very similar or have most similarities with all other electric vehicles, car, truck, and commercial, it actually applies to school buses as well. It's organized in a standard arrangement so you can easily find the mandatory rules, what's permissible, and also just explanations of why the safety practices are important as it relates to NFPA 70E. Roll me forward. Other documentation that's out there related to keeping you safe is an emergency response guide that all manufacturers use to identify where high voltage components, the batteries themselves, components that are powered by the batteries, modules, inverters, wiring schematics, and of course, cut zones and no cut zones are located. It also then goes through looking at and assessing the situation for occupants and those around the vehicle, a vehicle that may become submerged in water, and also really the practices around moving this bus, right? How do I get it out of where it's at if it's disabled? So towing practices as well. And these are obviously not part of NFPA 70E, but they're available. Most of them are available quickly and easily online. Roll me forward. And as with anything that you're doing mechanically, electrically, or otherwise, certainly just regular existing electrical safety guidelines apply to those that are approaching, interfacing, or entering into the world of doing repairs on these electric school buses. So you want to make sure that simple cautions and dangers are adhered to, and that the right personal protective equipment, the right tools, and the right actual training through NFPA and beyond through the manufacturer are adhered to keep you safe. Roll me forward. So in the case of the electric school bus, you have your traditional, 12 or 20 volt, 24 volt DC functioning system that operates the lights, the radio, the battery that initiates the actual powertrain to start and run. And those are typically sub 50 volts. Again, they're 12 to 24, which are common in the marketplace. DC systems operated off of conventional batteries. What we're looking at here is going into defining high voltage, which is really anything over 50 volts DC all the way up to 1500 volts direct current or DC, and anything over 30 volts up to 1000 volts on the alternating current side or the AC side. So that's the definition of high voltage. So really, 30 on the AC or alternating current side and 50 on the DC, that's not very high voltage in your mind, but is considered and deemed to be high voltage as you're working through electric vehicles, including the electric school bus. Roll me forward. So electricity, obviously flowing through the body can be and cause discomfort at the bare minimum, but can also cause injury or death. And it's really about the actual voltage itself and you being the ground path for that voltage to reach ground. So the path of current, if it flows through the body, the amount of current as measured by volts and amps, and particularly the amperage is important, can actually go through and cause shock to the body itself. At 1 milliamp, so one fraction of an amp itself, a slight tingling sensation can be felt, can still be dangerous under certain circumstances. When you get up to 5 milliamps, it can start to be actually painful. Again, this is less than an amp of current. When you go over to that half amp, it can become painful shocks. You can actually begin to lose the control of your muscles, which causes you often muscles to lock up and making it difficult to let go of what's happening. Once you get up to the 17 to 99 milliamp, it can be things in excess of that can actually cause respiratory arrest, muscle contractions, and even obviously with respiratory arrest and muscle contractions, death. So then when you get into obviously higher amperage than that, you're getting into heart actual signals that are cause issues. So then muscles and hearts and death is obviously likely. Anything over 2 amps, it's death is very possible, as well as burn. So it's very important to understand that even low amounts of current in the high voltage range can actually cause harm. Very, very important. Roll me forward. And just kind of an actual graphic representing threshold of sensation when you're looking at milliamps and going all the way up to the 100-watt light bulb there. Obviously when you get into the middle of that, 1/10 of what it takes to light a 100-watt light bulb at that mark can certainly cause your heart to stop beating, can start breathing to stop. So it's again, even though it's low numbers, it can still be high voltage, and the amperage of the current that it's carrying can be those things that cause damage to the heart, sensitive organs, even the brain. So one thing to be sure is whenever you're encountering voltages that are considered to be in that high voltage AC or DC range, always assume the circuit is energized. Moving me forward. Beyond just your connection to the body from the electrical source to ground, there's also arc flash and arc blast that also can have detrimental effects on the human body. Arc flash itself is the actual light emitted when you disconnect a circuit. So what happens is you disconnect a circuit, and that current flowing actually then jumps through the gap known as the air gap itself. And that can cause a very bright flash itself. That flash itself from that arc faulting can actually cause blindness. It produces a lot of heat, so it can cause heat burns. But even more important is it'll often create an arc blast, which is actually the wave, sonic wave that comes from that flash. So high temperature, very bright light, causing an actual shock wave to be carried through the air. And that pressure is powerful enough that it could even knock you down off your feet It could cause damage to your lungs, your brain, eardrum, inner ear damage. And again, this is beyond the high temperature and light that's emitted from the arc flash. This is the blast that's actually felt beyond. So you have to be understanding of where those actual current carrying connections are being disconnected, and make sure that your workers are safe, and always be safe when you're approaching somebody that's working on the electric vehicle, especially on the high voltage side. Roll me forward. So going even beyond and further, there's direct, which we talked about, right? Electricity going through the body causing an electric shock. But then you have others, which are indirect, which are falls and even potential fire, right? So those things could occur as well as a result of coming in contact with electricity. Right, roll me forward. So as you're starting to prepare to work on the electric school bus, you really have to know the hazards, know the equipment that you're using, make sure that you're using the practices that are defined in 70E and in the material that's provided by the manufacturer. Make sure you understand the PPE that's required as well. And always, always, always make sure that you've got permission to work on circuits that are energized. Right, roll me forward. As part of that OSHA Act, it's really the employer's responsibility. So if you're someone that's actually employing a technician, a maintenance person, somebody that's working around the bus to actually start doing repairs and interfacing with the high voltage side, you got to furnish the employees with information about recognized hazards, what could actually cause death or serious injury. And obviously, if you don't comply with that under the act, there obviously are penalties through OSHA that can actually be instilled. OSHA does investigate incidents that occur with high voltage situations, whether it's electrocution or things that happen beyond that. And you can find more information at www.osha.gov. Roll me forward. And it's also important to, again, as we mentioned earlier, to know NFPA 70E. So employers must be able to understand the hazards posed by flames, electric arcs. All those things are contained in reading through information in 70E. So you're going to want to actually do some planning around what could happen around the job as you start to get into working on the high voltage side of an electric school bus. Roll me forward. So some key areas to think of, like any other repair, you should have the same plan in place, but particularly for an electric school bus, you're going to have to think about safety management, how you're going to safely manage those that are around the vehicle, those that are maybe in close proximity to where you're doing the repair, how you're actually executing the repair, what your plan is. Then you'd want to do an assessment of things that potentially you need to think about to keep those around you as well as yourself safe as you start the work itself. You need to identify what personal protective equipment would be required for the task you're performing. And then if something does go wrong, it's always good to have a hazard response plan and know exactly what you're going to do to respond should something go beyond what you had expected to during the actual repair itself. Roll me forward. So safety management and all these elements come from NFPA 70E. So it's really basic electrical for your organization, the safeties, procedures, training, and equipment that are needed to really keep you safe as you start to work on the electric school bus. Roll me forward. Doing the job assessment is also contained inside of NFPA 70E. So it'll walk you through the requirements. You want to make sure that you're adhering to those NFPA 70E programs and procedures, and they should be part of your organization's procedures as you're starting to have an interface on the electric school bus with the high voltage side of the vehicle. So make sure that you're familiar with that portion of NFPA 70E to be able to form a job safety assessment for each job you're going to perform. Roll me forward. We're going to touch on personal protective equipment later, but NFPA also prescribes, depending upon the actual function, what actual PPE is required. And again, we'll touch on that more in depth as we go through this presentation. Roll me forward. And hazard response is you don't always know what's going to happen, and you can't predict everything in every situation. So that's why you have a hazard response. NFPA explains and gives you guidelines on how to protect the surrounding environment. And if something does happen, what you can actually do to be able to make sure you have the right actions in place should a hazard occur. And roll me forward. So the difference between hazard response categories and job safety assessment is really being able to look at the actual operation that you're going to do and do a good assessment to look at risks from all different angles and hazards that might be part of the job. And again, this might not be right at the electric bus itself. It could be other equipment that you're using to charge, like a charging station. It could be shop equipment that's used to measure voltage. All that needs to be taken into consideration as you're doing your job safety assessment and the corresponding hazard response. It may even be the way you cordon off the vehicle as you're doing work on the vehicle. And we, again, along with PPE, we'll be talking about some lockout tagout as we go through as well. Next slide. So here we are again, we'll be talking more about this in detail, but understand the procedures to be able to keep energy sources, and electricity is an energy source, safe from harm from those around something that you're actually performing work on or that you're work in process. So you want to notify others that you're doing that work in the area, and certainly you want to have proper signage to show that a piece of equipment or the part of the electric school bus you're working on is not operational, but still may be dangerous. So you want to make sure that you keep people safe, including only allowing access to that to those that have the proper training. And roll me forward. And the final step before going into doing high voltage work on the electric school bus is to truly, as you've gone through the manufacturer's procedure for disabling high voltage, validating and using the correct tools, in this case a voltmeter, to read the manufacturer's prescription and make sure that that actual portion of the vehicle and battery and or high voltage system is truly isolated from energy. There's no energy flowing through it. And you would need an actual deliberate attempt to reconnect and reinitiate to be able to get that piece of equipment, in this case an electric school bus, back up and running and functional. So you want to verify isolation. Roll me to the next slide. So where are we at today? At the beginning, I mentioned level 1, which is what we're actually in process of doing in many locations across the US and Canada. And that's really providing all those constituents that have interface with this bus. I call it the partition between the high voltage side and what's normal. So, filling washer fluid, yeah, that's a normal exercise, no different on an electric bus than any other internal combustion engine bus. Changing a headlight out, the same thing. But it gets into high voltage components that may need isolation or may need specialized technician training. That's when you're going beyond just disabling high voltage for a vehicle to be down. You're now disabling high voltage and testing for the presence of voltage, preparing for a high voltage component to be contained. So level 1, you're staying on that low voltage side, the safe side, but you're acknowledging that you understand what's needed to be able to disable, test for voltage, and make sure that you've got personal protective equipment for doing maintenance on the vehicle. Roll it to the next slide. Where we're getting to as these vehicles come out of warranty is what's level 2 high voltage technician training. And again, these are able to be referenced in NFPA 70. And it's that you receive actual HV electrical training, and you demonstrate the ability for the operation, repair, and on the high voltage side, and what the construction and operation is of the architecture of that system. And you're going to have to maintain, obviously, an electrically safe work area. Know what PPE you're going to be actually using, the proper procedures for the actual repair itself, and high voltage systems and components that you're going to need to test and be sure that they're disabled and they don't have energy flowing through them. You really want to make sure in this step that if you're going to do work on the high voltage side that you've gone through and have all the procedures to make sure there's no energy flowing. And then roll me forward. Very few technicians doing this work today other than under warranty, but it's things like the high voltage modules, inverters, converters, DC to DC buck boosters, air compressors for powering the air brakes and air suspension, the power steering pump, power brake booster for a hydraulic brake electric school bus, and the thermal management unit to warm the batteries with a high voltage heater and cool the batteries with a high voltage compressor. So you're going to want to understand what's happening with the component when somebody actually says it needs service, what the NFPA 70E requirements are, how they apply, what does actually apply for what you're doing, and what requirements that you need to meet PPE and otherwise to be able to do the repair on a level 2 system repair. Roll me forward. And then this is really emerging, which is called HV battery servicing or level 3. Small number of people today throughout the country have completed this training. This is when you're going to actually go inside a battery, going into the module or sometime down to the cell level, or battery management system, the cabling and the bus bars that carry energy. You're going to want to make sure that you know exactly what PPE is required. You know, safety helmet, shock hood, face shield. All those are very, very important. Make sure you have class 0 tested insulated gloves that give you protection up to 1,000 volts with the leather protectors. Again, this is as batteries start to age and go out of warranty, going to become more commonplace. Today, it's done by a select few, and NFPA 70E can give you that category 2 requirement. Even things like minimum arc ratings are super important because failure to follow this procedure, and this is all with level 1, 2, and 3, can result in serious injury or death to the actual person and or people that are around this vehicle and or the equipment that's being used around the vehicle if you're not properly trained. Roll me forward. All right, and that gets it to questions and answers in this section.
Yeah, thank you very much, Brad. Well done, very informative. And we'll take some questions for Brad. If you go down to the bottom of your screen, you'll see the Q&A icon. You could click on that and type in your questions. Let's start with the first one. Brad, where could people get a copy of NFPA 70E?
Yeah, so NFPA 70E most commonly is used in book form, right? So it's still a book today. It can be purchased online, new or used, right? And if you get a used NFPA 70E, you want to look at the edition, make sure it's got the things that you actually need and the most up to date. But you know, you'll find them out there new at commercial and industrial sites. Walmart.com has them. They're pretty easy to buy from sources. Even eBay has them listed. So again, the best form is the written form and book form. You can also then, if you need to, have some that go onto a tablet or onto your smart device that you can refer to as you need to.
Okay, and there's someone has just entered a link to get that for free.
Very good.
Very good. Brad, could there be a risk of electrical shock to either passengers or the driver? And if not, what protects them from it?
Yeah, so as we do driver and technician maintenance training and first responder training, you know, these buses, no matter whose it is, are up to an IP rating, which is the water intrusion rating of those electrical components. And the IP rating that's required prevents you from coming into contact with high voltage on that vehicle, regardless. Even if the vehicle's submerged in water, right? You went through some water, it keeps that high voltage electrical isolated to those components into that battery pack. So look up the IP rating for your manufacturer and make sure it meets your requirements.
Okay. How is high voltage grounded to the bus?
Yeah, so in the case of your low voltage side, the lighting, the radio, being able to start this bus, which is usually 12 volts and sometimes 24 volts, that's grounded the low voltage side through the chassis of the bus, right? So you typically ground through the chassis and you're providing power to the components. In the case of the high voltage side of the bus, that energy is basically contained through, there's a Federal Motor Vehicle Safety Standard 305 electrical isolation that has specifications to not allow the high voltage, either positive or negative side of a DC system or the inverted AC system to be in contact with any part of the vehicle itself. So it's electrically isolated is what it's called. So high voltage is electrically isolated. We actually use a high voltage interlock loop to be sure that if any portion of that system is disrupted, that it actually causes high voltage to isolate itself into the battery pack itself. So again, isolation is how we keep the riders in the vehicle and the chassis from the vehicle from coming in contact with high voltage.
Yeah, that's important to note that the high voltage is completely isolated from the rest of the bus. Yeah,
Yes.
from any traditional grounding that would occur on the low voltage side. Now, in a case if there's a flood like Hurricane Helene, I guess the same safety precautions apply. What would you do? What would you do if an operator all of a sudden found himself or herself in knee high in water, the bus,
Yeah.
and needed to?
So, and that's happening, right? It's just happened here in the last few days. With that, you would treat this as a school bus first, right? So if there's people or passengers or a driver on the bus, you want to follow the same safety protocol on this electric school bus that you would follow for any school bus. And then the second piece that dovetails into it is to be able to follow electric vehicle procedures, right? So first responders are starting to get used to the millions of electric vehicles, passenger cars, trucks, and now this commercial vehicles like school buses on the road. And the same thing would apply to an electric school bus that would apply to an internal combustion engine vehicle, where you're going to want to follow the manufacturer's recommendation. You're going to want to look at NFPA in the case of the electric school bus, NFPA 70E, and you're going to want to follow before you try to reinitiate that. And again, this would be the same as starting a diesel bus back up. You're going to want to follow those procedures before you start to reinitiate the bus. Depending upon the situation and the severity, certainly an electric bus, like any other internal combustion engine bus, can be and gone through the procedures to check and make sure that there are no fault codes. Everything seems to be fine. All the components check out, and the vehicle may be able to be returned to service. If you find any sort of fault codes or there's some damage that is visible to the components on the vehicle, then you'd have to check those vehicles, replace or repair before you can actually put it back in service. But very similar to an internal combustion engine vehicle, just different processes. You just want to do that due diligence.
Okay, just one last question before we get to Brandon. You mentioned keeping a safe distance between these buses when you're working on them in the shop. Is there a recommended distance? How far is safe enough?
So, and that question is answered in NFPA 70E, where you stanchion off the vehicle itself so that you make sure that nobody's within close contact when you're doing high voltage work. So refer to 70E, but you also have to think about where you're working, because roadside work, which happens from time to time, is going to be very different from shop work, which is going to be very different from yard work. So you're always going to want to have the safe distance, and your district's procedures on how you do that with your buses will also, as part of 70E and your district's policies, will guide how and where and how to keep people safe as you're doing work on these buses.
Okay, Brad, thanks again. Very well done. Thanks. Now we'll go over to Brandon Reed. Next slide. Okay, Brandon, we'll talk about worker protection, a little bit more detail on PPE and so on. Brandon.
All right. Yeah, thank you, John. As mentioned, my name is Brandon Reed, Director of Customer Success for Lion Electric, and we're going to go over worker protection today. Got a few topics to review. Go ahead, next slide. And yeah, those are going to be just how to safely begin work on or near a high voltage piece of equipment, identify the proper equipment for working on electric vehicles, and discussing high voltage worker considerations. And go ahead. Yeah, so I wanted to start by sharing a little bit of OSHA data on electrical related injuries. This is not fun for anybody. We don't need to go into too much depth, but this stuff is critical for your own safety. That's what we want to take away from this. So as you're managing your shop, your employees, yourself, Keep this sort of thing in mind. You know, I want to point to one bullet point here. The data is covered from 2020 for all industries, and the third bullet point does say that 1 in every 20 electrical incidents are fatal. So keep safety at the top of your mind whenever you're working on or around an electric vehicle. This data is not really specific to the automotive industry. It's either not big enough or it's not, or it's a little bit too specific to where they don't point that out. So there's no standalone information. But again, use this to illustrate that special safety considerations and steps must be taken when working on a vehicle with a high voltage system. And we'll talk about more of these throughout the presentation today. Go ahead and move forward. So yeah, what you need to know. Vehicle information is always an important one when you're working on or near high voltage equipment. So, you know, especially in the case of an emergency, what we need to know is the make, model, and type of electrical propulsion we're working with, whether that be hybrid or electric, full electric. And any vehicle specific safety information that the manufacturer is recommended, you know, pop to your owner's or safety manual on that one and make sure to familiarize yourself with it. And then just, again, in case of an emergency or something like that, just a little bit of basic operation, how to move the vehicle a short distance, put it in park, set the brake, turn it off and on, activate the hazard lights, some very basic items before you dig too far into it. And next slide. Another item to keep in mind is the labeling. So these are going to inform you of the presence of high voltage in the various components around the vehicle, you know, your batteries, your cables, high voltage modules, other specialized items. It's also important to know that personnel working with high voltage must be specially trained. And, you know, you've got to follow the manufacturer's instructions on opening and repairing these components. We'll go over this just a tad here, but our next presenter will review some training options. Lastly, as a rule, all high voltage cables are a neon orange color. So they're pretty easy to see, easy to identify, and take a little bit of special caution around. Now, one thing to note here, in very few vehicles, mostly where there might be two different high voltage systems side by side, there is a chance that these cables might be a bright blue. Wanted to point this out, but it is extremely rare. And once again, please just refer to your manufacturer for the instruction on cable colors and things like that. And moving on next. So safety plan, another thing you need to know here. As with any job, and as Brad previously mentioned, you need to have some sort of safety plan. You know, a safe, clean, dry, adequately lit workspace should be a standard for any job. Familiarity with your organization and building safety guidelines. Know where your exits are, know what to do in the case of a safety problem. And then removal of any conductive or metallic items from your person and or your pockets. You know, this can be a watch, jewelry, belts, phones, etc. Anything that conduct electricity. And number 4, make sure you're not working alone. Never work on a high voltage vehicle without first notifying somebody who is trained in dealing with high voltage safety procedures. Again, that's just having a backup right there. And number 5, inspection and proper use of all required PPE and tools, which we're going to hit on in an upcoming slide as well. And 6, a secured and clearly marked work environment. The idea there is to just keep non-trained people away from the area, and we'll get into this a little bit more later. And 7, getting into that in a moment as well, but de-energize the circuits and verify the absence of voltage by doing a few tests and, of course, a lockout checkout. Next slide, please. So equipment to work on electric vehicles, what we're going to get into now, and everybody knows what PPE is, personal protective equipment. These are special items needed to safely work on or around high voltage. Like, you know, one of the most important items here that we're going to focus on to start is going to be your rubber insulated gloves and leather protector gloves. You've got to have both. And just like the name says about rubber insulated gloves, these are going to protect your hands from electrocution, from electricity. There are 2 classes that we're looking at today. That's going to be class 0 and class 00. So before you purchase these, just be aware of the systems that you are going to work on and on specific vehicles that are in your fleet or in your shop. So as you can see, and as you've heard, probably the voltage in these vehicles can vary just a bit, anywhere from 300 to 900 volts DC. So a class 0 is not always going to meet the minimum or maximum, I'm sorry, voltage of some of these systems. So class 0 might be needed in some cases. The leather protector gloves are also a must-have. So these need to be large enough to fit over those rubber gloves and completely and comfortably fit over the hand, allow good movement and all that. So we can protect those rubber gloves right there. Do not forget these. Otherwise, you're going to run the risk of damaging and allowing a pathway for energy to flow through your gloves if the skin is exposed. So very important that we've got both things there. And as you can see, there's a small little illustration. Rubber insulating glove goes on first, leather protector goes over it, and there we go, all good. So moving on to the next. So staying on the topic of gloves, we'll stay on them for a few slides here because they are critical. And for some of you shops, this will be a new item for you. But before you start to work on any lockout, tag out, before you do anything with electric vehicle, always, always, always inspect your rubber gloves for the following. We're going to look at cracking and cutting, snags, physical damage, chemical attack, UV checking, and in any folds where the rubber might have been strained, folded to a point where it's stretched it and damaged it. Again, the idea here is to just ensure that the gloves are not damaged or worn excessively to make sure that they're maintaining their insulating properties. Next slide, please. And how we can do these tests, how we can ensure that those insulating properties are maintained is by doing what we're going to call air tests. And there are two of these. The first one is going to be a blow and fold. Essentially, you take your glove, put it up to your mouth, blow some air into it, and then roll it up tight and just inspect for any leaks, any damage, again, anything that was on that last slide. There's also going to be a glove inflator that is available to do these tests. This is going to be a tool that you fit the glove over and you actually pump it up and it will fill that for you. Does a little bit more of a thorough inspection, allows it to maintain that pressure for a little bit longer. And again, this is going to be our higher level inspection right there. So the goal of both of these air tests is just to identify if there are any perforations that could potentially cause a breakdown. And the best practice right here, folks, is to probably schedule a regular periodic inspection of the gloves, including a consistent air test. Again, best tool being the inflator. If it's up to me, I would probably do one of these every 30 to 60 days, and of course, a daily inspection by doing just the basic air test yourself. Each one of these gloves is labeled with a test date on it. You can see that at the bottom right there. There's going to be some sort of tag, whether it be red, white, what have you. And that's going to be a qualified, recognized lab that has tested these. So it is required that these gloves stay within their test date. And again, that's just to maintain security and knowing that you are going to have those insulating properties. And as with any PPE, folks, you are the one that's responsible for the ongoing maintenance and inspection of the gloves that you are wearing. Your shop leader can manage the periodic inspections, testing, certifying, purchasing programs, but no matter the test date or safety program, your shop has a thorough inspection before you use each one of these gloves could save your life. Moving on, please. So just a few other things to have while you are working on electric vehicles. We're going to have our fiberglass rescue hook, and what that is, just in case somebody has grabbed onto an electrical circuit and is locked on, cannot let go. That will be used to remove them from the circuit, uncomplete that circuit. Always have your safety glasses, natural fiber clothing when we were working on this sort of things. We do not want any synthetic fibers here. And EH-rated safety boots. So those safety boots, believe it or not, can have a steel toe. They can also have a composite toe. These are tested and rated to up to 18,000 volts for up to a minute under dry conditions. So there are really no classes to the boots. There's not class 0, class 00, et cetera, like there are gloves. So again, make sure we're having all these things on hand and on our person anytime we're working on these. Next up, we'll talk about some tools. So insulated hand tools, and we read through here. These are a little bit different than what we're used to. They're not our standard tools, our standard hand tools, and mostly I want to stress that that we're using these on any component that has high voltage going through it, whether it has been locked out or not. So whether it's been de-energized or not, we want to make sure that we are using these. Again, we do not know if there's a possibility that they could re-energize. And we want to just make sure that these are in our hands at all times when we're working on these components. So if they have been safely locked out, we want to use these, but due to these requirements, guys, it might be preferred for shop leaders or a supply or an inventory to have a shop set. Oftentimes these are sold in kits, which is quite nice, and having a shop set kind of makes it easier to ensure that there aren't any techs out there that are using these as their everyday tools. This will accelerate the wear, obviously, on these, and you will find that these insulated tools are a little bit more costly than their non-insulated alternatives. The test date is also stamped on these tools as well, just like our gloves. So, follow manufacturer schedule for retesting and replacing on that one. And then, beyond that, there may be specific tooling set out by each manufacturer or vendor to work on their buses. So make sure you get with them before working as well. Next up. So this was a question on the last presenter, actually, but we've got a high voltage safety perimeter that we want to install around each vehicle prior to locking it out. So what this is, it's an obvious, highly visible barrier or marking that surrounds the entire vehicle. And the point is to just notify others that high voltage work is being performed. We want to prevent untrained, unfamiliar, unprotected folks from coming into contact and exposing themselves to possibly lethal voltage. Again, done before any sort of locking out and tagging out, and certainly before any high voltage work is performed. A couple ways we can do this. You see illustrated in the photo here is we've got a real nice specialty high voltage barrier, but we can put up cones, caution tape, again, just whatever is obvious and highly visible that's going to make sure that people around do not enter it. So you can remove this once all high voltage components have been secured, verified safe, and all lockout tagout equipment has been removed. Essentially, we know the vehicle is now safe. You can remove it, and do not remove the safety perimeter unless you are the person that installed it. Kind of a standard rule with lockout tagout. And next up, we'll go into lockout tagout tools. Thank you. So last but certainly not least, we're going to talk about all of these. These are going to be used to lock out and tag out a vehicle and verify de-energization. And verifying zero voltage, right? So please note, this may not be a complete list. Once again, please check with your manufacturer for anything additional, but these are going to be our generic items needed for any procedure. We all know about the lock and hasp, as well as the tag. This is a part of your standard lockout procedure, and there's going to be places for the physical lock in each part of the vehicle that needs it. This will be the addition. You will need a Cat 3 multimeter. And what that's used to do is just verify that once locked out, you know that there is zero voltage remaining in the system before you start working. So pretty basic there. We'll move on. So now we're moving on to our next topic here, which is working safely on or near high voltage electrical equipment. We've hit on this a lot already today, but safety is a primary consideration when we're working around this equipment, right? So first, we want to point out to always follow OEM instructions when de-energizing an electric school bus. There may be specific things not noted here. So we're going to pay special attention to that. So generic steps, once again, are going to include equip your PPE, make sure you've got your safety plan, and ensure the vehicle is properly shut down. And this is one thing that I do like to mention in this modern day and age where we've got keyless entry, keyless fobs, keyless start. If the vehicle that you're working on has anything like that, ensure that this keyless fob is secured outside of any possible detection range. So don't keep it in your toolbox right in front of you. Don't keep it in your pocket. If you're in this situation, you might have a special spot just for that. And then we're going to locate all the high voltage and low voltage disconnects. These can include, your switches, cables, and connectors, other manufacturer service, or special disconnects from a high voltage battery itself that are on the battery. Next up, we're going to isolate the high voltage energy by turning off or removing all means of disconnect, and wait several minutes for the energy to dissipate before continuing to the next step, which is going to be an LDL test, or a live dead live test. So those are the very basics to de-energizing a vehicle. We'll talk a little bit more about that going on, but next let's move to the LDL test. So as I said, this is our live dead live test, and it's done using your Cat3 multimeter, and it's going to verify that the system has no voltage, 0 voltage. And it's also going to let you know that your multimeter is reading accurately and correctly. So here are the steps for that. The first thing we're going to do is we're going to check a component with a known voltage, and that can be the wall, I think, is what we just saw in the previous presentation. You can check a 12-volt battery. You know that that's got a known voltage, or a power tool battery. Again, if you know the voltage, you know what it should be. 12-volt battery, for instance, and we get a reading back that verifies that, you're good. You have verified that a live circuit is live and your meter is reading correctly. And then at the dead vehicle, we are going to, or at the electric vehicle, I'm sorry, we're going to measure the voltage of the circuit or system that you believe to be dead and verify the absence of voltage. You should get a reading back of 0.0 volts. And once you've done that, you're going to go back to the live circuit once again, the same one that you just measured off of your known good voltage, and just ensure that your meter is still operating correctly. So that's going to close the loop. That lets you know that your tooling is correct, you've got 0 voltage, and that you have tested before you touch it. Just a good thing to follow. Always test before you touch. All right, moving on. So now it's time to perform the lockout tagout procedure. And as you all know, this will physically isolate the source of energy, making the bus safe to work on, and will allow there to be a prominent warning that's going to state the vehicle is de-energized, not to re-energize it, and communicate who tagged the vehicle out. We all know this from our typical PPE and lockout tagout processes. So lockouts, once again, apply that to the switches, cables, and various other locations. There will be vehicle-specific procedures and instructions. Check with your OEM, and your employer is responsible for providing the training specific to the vehicle and needs of the qualified person working on the vehicle. There do need to be qualified professionals before working on a high voltage system here. Next. Okay, so lastly, we're going to go with just a few worker considerations to wrap up here. This is just kind of a critical summary of the items that we've discussed already. The one that I think is most important here, guys, what I want everybody to take away is just always assume that voltage is present in the system until you've personally verified the system is safe. So again, doing our live dead live, doing all of our checks to make sure that we are safe before working on those components. Pay special attention to the certification, the test dates, condition, proper use of your PPE. Ensure you aren't working alone when around high voltage. Again, having somebody else that is close by is important. And as a part of the next point, be prepared, all that sort of thing. And part of being prepared is having a second set of PPE ready if needed to. So somebody else that is in the shop, somebody else that has been either previously decided, or just the buddy working next to you, whatever it may be, have that second set of PPE ready if needed to. Lastly, follow a consistent safety plan. If you're doing the same thing every time, you are probably going to be safe, and you are not going to get complacent, which is important here. So easy to do, but again, remember that we are working with something that can be deadly, and to pay attention and try to stay safe at all times. And for me, that will conclude the portion. So I'll take some Q&A here, but thank you all so much for your attention. It has been a pleasure.
Thanks, Brandon. Well done. Good job. A reminder, there's the Q&A icon at the bottom. Type in any questions that you have. The first question to Brandon is, are there any special cases or boxes to put the key fobs in to block the signal?
Not as far as I know. Again, as long as it is out of the range, it shouldn't matter. And of course, each one of these fobs has a specific range where it can usually engage it. So once again, check with your manufacturer on that. But no specific case or anything like that. I would just recommend a lock box for those keys on that.
Okay. What are some safety considerations for pre-trip inspections? Do drivers have to wear PPE?
No, they do not. I don't think we certainly don't need to be wearing our rubber gloves and all that sort of thing. The cables and the high voltage components are safe to touch as long as, of course, they're in good shape. They're in good condition. You should not need to interact and interface with these components and cables on a during a pre-trip. This is nothing that we need to check. One thing that I typically point out to people is just we're only visually inspecting all of these things. We don't need to do any pull tests. We don't need to do anything other than just a visual inspection. If there is, if there's anything obvious, if there is any damage to the cables or components, or something that looks like it should be there and it's not, or vice versa, of course, we want to call that out. But no, we are using our eyes. We're not using our hands. We're not needing any specific PPE for that.
Okay, and no shock hazard then plugging or unplugging the cable to the bus charger
Yeah,
cable.
no, there's no shock hazard when you're doing that. The only thing that plug is going to have is just a very, very, very small trace voltage that is just a basically pilot voltage that's looking for the charger to communicate the voltage as well. So that's again very, very trace voltage, no damage to that. You can drop the cable in the water. Um, you can do you can do a lot with that cable without worrying about it. Again, if you see any damage to the cable or to the connector, again, please lock that out, tag that out. But no damage during plugging up the charging is negligible.
Okay, that's good to know. Where could school districts obtain PPE and what is the expected cost to them?
They can get it basically from anywhere that they're already getting their PPE. I'll use the company Granger as an example. If you're already getting your normal rubber gloves, your safety glasses, your knee pads, whatever from them, they should also offer that set of insulated gloves, insulating tooling. So you can really go to any safety equipment carrier within the U.S. and get that sort of thing. And as far as cost, I can't really say anything specific, but what I can say is that it's more than likely going to be more expensive than what we are used to. As I mentioned, for the insulated tool kits, it's going to be a bit more, and the insulated gloves and whatnot are a bit more than our typical gloves that we wear. But again, this is to protect against high voltage, so it is worth it.
Okay, and assume that Lion and other OEs have a list of recommended PPE for use on their buses. I know you went over all of them here,
Yeah.
but you also must have those in your training materials.
Correct. Yes. During any lockout tagout training, or in your owners and safety manuals, it will have a list of specific PPE. And if you don't see that, always please ask, and
Okay.
we will have something that we can supply to you.
Okay. Can technicians share insulated gloves and other PPE, or should they have their own? What's your recommendation on that?
I'm going to say they can, but with anything that touches somebody's skin, it's not necessarily a safety issue as much as it is, health. I would think, you're putting your hand in somebody else's glove that they've been using all day. You never know what's going to be in there. But if you are using somebody else's gloves in a pinch, again, make sure you're always testing, make sure you're always checking, doing the air tests that we've previously talked about. So I will say that yes, you can, but more for your own safety and health, I would recommend against that.
Okay. Do you recommend that school districts purchase a dedicated testing device for insulated gloves? One that
Yeah,
blows up the glove by
I
itself?
would. Again, the daily check of doing just the blow test is good, but having the inflator is going to be just a little bit more of a significant test. It will hold the pressure for a little bit longer. Any extremely small pinholes in that case are going to show themselves, whereas maybe on a lower pressure blow, or somebody that hasn't really gotten a good seal when they're holding it themselves, that's going to be able to expose those sort of problems with your glove. So I would recommend that. And again, anywhere from 30 to 60 days, I would recommend using that testing device, if not sooner, to test all of the rubber insulating gloves.
And with two sets of gloves on each hand, is it awkward to do routine maintenance tasks?
Yeah, but as soon as we have those things, well, let me back up. As soon as the vehicle is completely tagged out, we've verified 0 voltage, those gloves can come off.
Okay. Okay,
Yes,
that's good to know. Okay, I don't see any other questions here. So again, Brandon, thanks for that. That was very good.
my pleasure. Thank you.
Okay. And our last presenter is Angel Yin, and she will describe some of the required skills and knowledge that technicians need to have as they work, maintain and repair these electric school buses. Angel.
Thank you, John. Next slide. Good to see everyone. So in this presentation, I'm going to compare the similarities and differences between an internal combustion engine school bus and an electric school bus. I will also outline the specific tasks that technicians need to perform when working on electric school buses. And then we'll talk about the background skills required for ESB technicians and explore where to acquire these skills. And then finally, I will provide recommendations on the certifications and qualifications needed to work safely and efficiently on electric school buses. Next slide. Okay. So before dive into the skills needed for maintaining an ESB, it's worth comparing the ICE buses and electric school buses, as well as the differences in maintenance requirements. So for ICE buses, technicians focus on maintaining systems like the engine, exhaust, and fuel systems. These are mechanical components that require regular checks to keep the vehicle running efficiently. With ESBs, there are similarities such as body maintenance like doors, windows, and seats, and low voltage systems which manage climate control and telematics. However, the biggest difference lies in the high voltage systems, which power the electric motor, battery, and the charging system. So these systems operate at voltages up to 900 volt, and they require specialized skills and precautions. Next slide. So from the comparison, we can kind of have a sense of the critical skills required for technicians working on electric school buses. If you already have experience performing maintenance on ICE buses, that's great. You already know how to work with the body, the low voltage system, brakes, suspension, steering, gauges and warnings, and proper towing methods. But since you will now be dealing with a different propulsion system, you will need to learn the EV prerequisite and EV advanced knowledge. It's important to be skilled in reading electrical schematics and understand how electricity works through the high voltage system, including how charging operates. Preventive maintenance is also crucial. Regular inspections and upkeep of high voltage system, HVAC systems, and charging equipment are important for ESBs. And then for more advanced skills, it's beneficial to understand how high voltage accessories function and be able to use diagnostic tools that help identify high voltage issues, such as charging system faults or high voltage disconnects. Next slide. And then I just want to emphasize again on maintaining your safety. So an ESB technician must be trained in high voltage safety protocols before performing any work. Any voltage above 30 volts DC is hazardous, making it essential to follow proper lockout, tagout procedures and use the correct personal protection equipment. And then understanding the risks and knowing how to mitigate them will protect both you and the others in the workplace. Next slide. Now, where do technicians acquire these skills? Well, there are several excellent training programs and resources that provide the necessary skills for working on electric school buses. For example, many community colleges offer electric vehicle technology certificate programs, which provide a solid foundation in electric vehicle maintenance and safety. These courses are available both online and in person. And then similarly, trade schools may also offer hands-on training in electric vehicle maintenance. Employers also play a significant role in technician training. So if you are working for a school district or maintenance service provider, check with your employer about any existing training programs that they may offer. For those looking for government-backed programs, the EV champion training provided by the National Renewable Energy Lab is a great resource. Additionally, there's also private organizations such as the Transportation Technology Service Professionals that offer online trainings that are accessible nationwide. And then lastly, always check with your OEMs and dealers to see if they offer technician training. I believe nearly all OEMs provide training specific to their vehicle technology, which is a great opportunity to learn about the exact vehicle you will be working on. I know sometimes it's hard to gather information on available training programs, so I'd like to highlight a great resource that I found particularly useful when doing my research. The WRI Electric School Bus Initiative has posted an electric school bus technician training database online, which contains both online and in-person programs available across 19 states. I think this database is a great start point if you are looking for a training program that suits your specific needs. And I think we will send out the slide later. I've embedded some links. You can check it out afterward. Next slide. Okay. So beyond some formal education programs, there are also certifications available if you are looking to further validate your ESB skills and knowledge. Today, I want to highlight 3 certifications that are widely acknowledged in the industry. First, there's the NFPA 70E, the standard for electrical safety in the workplace. So previously, as Brad mentioned, the NFPA 70E outlines the necessary procedure and safety measures to mitigate risks when working on or around electrical equipment, especially high voltage system. This is a great certification to have, demonstrating that you have a thorough understanding of electrical safety. And the next is the certification offered by SAE International in Vehicle Dynamics, Diagnostics, and Electrical Safety. This certification shows that you have a deeper understanding of electric vehicle system, diagnostics, and safety protocols, which are critical for working on ESBs. And then lastly, for a more well-rounded skill set, technicians could consider earning the National Institution for Automotive Service Excellence, ASE certifications. So ASE is the industry's go-to certification organization for automotive technicians, and they've recently rolled out several EV-related programs. And earning these certifications demonstrate that you are meeting high standard of competence in vehicle diagnostic, repair, and maintenance. I know ESB is still an emerging technology, and as we advance in ESB adoption, I'm sure there will be more certifications and resources become available. Next slide. Okay. So earlier I mentioned that OEMs provide training for technicians, and now I'd like to share an example of the training we offer at RIDE to give you an idea of the type of information OEMs might provide. And after my presentation, if we still have time, I will invite the other OEMs joining today's webinar to share details about their own training programs. So for us, we offer tailored training for operators, technicians, and first responders. Technicians will receive the most comprehensive training with advanced options available upon request, covering almost everything from high voltage system to preventive maintenance. And then if you have any questions on our training program, feel free to reach out to me. Next slide. Okay, I think that concludes everything I have for today, and let's see if there's any questions.
Yes, thanks, Angel. That was good. A reminder to put your questions into the icon box at the bottom. And just to kind of reinforce what Angel said, she has plenty of live links in there. The ones that are underlined will take you directly to that site. So when this presentation becomes available, you'll be able to do that. Arnold Cruz is kind enough to offer this bit of information. WRI also released the Electric School Bus Training Standards, which define learning objectives and outcomes for people interacting with electric school buses. And there's a link to that. I think that's very important. We did that on the transit bus side. We've set up training standards, so it's good to know that they've also done that for electric school buses. Okay, let's see. Um, could the school bus districts assume that the diagnostic tools that you have a recommended list for those tools and they're available through each ESB OEM?
Yeah, I believe the OEMs will provide that.
Okay, so you have a recommended list and they could obtain that through you. Okay, who's responsible for certifying or qualifying the technicians to work on electric school buses? Is it the school bus district? Is it the school bus OEM? Who's actually responsible to make sure that the technicians have the knowledge and skills needed to work on these buses?
Well, that's a great question. I think right now, depending on who you are working with, if you are working on a school with a school district, definitely you should be certified by the district to work on anything related to ESB. But the OEM should provide you training, and there's quizzes, there's tests after the training that kind of certify that you are familiar with the vehicles that you will be working on. And then also in the industry, there's, like I mentioned, there's certification programs that you could pursue as well.
Okay, thanks again for that, Angela. I don't see any other questions. So we'll move on to the next slide where Angel did give an overview of BYD/Rides training program. I'll open it up to Brad and Brandon. And here on this slide is again the contact information for all the presenters. These are also live links to these sites. So we'll start with Brad. Do you want to just give a brief overview of the training program that Bluebird provides its customers? Brad? Okay, Brandon, are you available to do that? Or
Yeah,
Ryan?
I got you. All right, so we do offer in-person technical training as well as emergency responder operator training. But today it feels like we're concentrating on the technical training. So we do go over preventative maintenance, component location identification, lockout, tagout certifications. So we actually will come by and in person make sure that all your technicians or anybody that is going to be working on the vehicles is comfortable with that process. As well as just low voltage controls and basic diagnostics. So multi-day course based on size, class, and participation. And we just cover quite a few things, and that is done either at one of our facilities or at yours. And you see that Mehdi Shagagi is our listed contact for that. So if you are interested in more information, you can always do that. We also do have an online LMS platform, our learning management system. So that's going to be an online self-guided, very flexible, system that you guys can use that's going to have all the information that's in our in-person trainings and more. So whichever you prefer, Lion has got it for you.
Okay, thanks, Brandon. Looks like Brad has left, has fallen off the webinar here. But I'd like to thank each one of you for a very good presentation. I thought they were all very informative, and I'll turn it back over to Ryan.
Great, thanks, John. Thanks everyone for these great presentations. Go to the next slide. Really informative, like John said. And if anybody who's online here didn't catch module 1 or 2, those were also really informative. webinars, and they can be found at driveelectric.gov/webinars at this point. You can see the dates on here if you go scroll down, and you can find those. We are also working, as I said earlier, having all of these webinars, the slides, and the associated testing materials available for you. So if you didn't get a chance to have your technicians or drivers on any of these webinars, you can incorporate them into your internal training programs. Next slide, just one last one. So appreciate everybody sticking around till the end here. Like I said, if you have any questions, need any technical assistance, please reach out to us at the joint office. Technical assistance is offered free of charge, no strings attached. Go to driveelectric.gov/contact to get in touch with us. Or you see these links at the bottom. Obviously, talked about the webinars, or you can subscribe to our mailing list as well. I do see one more question on here. Despite all this additional trainings, is it still easier to maintain EV buses versus ICE in terms of repairs? Brandon or Angel, would you like to respond?
Yeah, I'll field that one. You know, we're all a little bit more familiar and comfortable with our internal combustion, obviously, but you know, in terms of ease and time that you need to spend maintaining these vehicles, I think it is less. I have experience in both worlds, and I can tell you that it's going to be a lot more computer troubleshooting and diagnostic based than actual mechanical. You're going to be a lot less dirty, I will say, when you're working on these electric vehicles versus something that's that's got a transmission, that's got fluid that you need to change, that's got oil pans and leaks and things like that. So your shop's going to stay a little nicer and cleaner. You yourself should once again spend a little bit less time because of the lack of some of these fluids and fluid filled components that are going to need maintenance. Typically, the motors that are used on electric school buses are going to be sealed. You can't break in, you can't maintain those things, you can't service them yourself. So they're, at the moment, the industry does have a few more components that are, again, sealed rather than easy to be worked on, broken into, and maintained and repaired yourself. But overall, the point that I'd like to drive home is that it is less just because of the fewer components that you're going to have to maintain.
Great, thanks, Brandon. And exactly, and I think a lot of that was also covered in module 2. So if you ask that question, you want to go review that, feel free, or you want some more on maintenance and repairs. So again, appreciate everybody joining today. And thanks a lot to our presenters. Really great. And we'll see you guys at our next module, hopefully in mid-November. Thanks a lot.